Hello, I'm Malavika. Today we are going to study the topic Python data structures, and we are going to explore the different types of Python data structures. First, the three main Python data structures are lists, tuples, and dictionaries. Understanding these is crucial for efficient data management and problem solving in programming. First, overview of Python data structures. The definition is that Python data structures organize and store data efficiently. They enable programmers to manipulate data in versatile ways and optimize performance. A comparison of the key features of these data structures, which are list, tuple, and dictionary. Lists are mutable and ordered, whereas tuples are immutable and ordered, and dictionaries store key value pairs, which means each has unique strengths for different programming needs. Next, the use cases of these data structures in programming. Commonly used for data storage, configuration setting, and managing collections. And choosing the right structure improves code clarity and performance. So here are the 6 use cases for list, tuples, and dictionaries in programming. First, list store ordered mutable data, which means lists are best for maintaining collections where order matters and frequent updates, insertions or deletions are required, such as managing student names, daily tasks, or dynamically changing data sets efficiently. Second one, tuples store fixed records. Tuples are ideal for storing immutable structured records like geographic coordinates, RGB color values, or database rows, ensuring data integrity where modification should not occur after initialization or assignment. Third one is dictionaries map keys to values. Dictionaries provide fast key-based access suitable for representing mappings like employee ID to details, word to meaning, or configuration settings, supporting flexible, readable, and efficient data retrieval in programs. Yeah, then we are going to deeply explore the each data structures. First one is list. So the characteristics and syntax. Python lists are mutable sequences, meaning the contents can be modified without creating a new list. This property enables flexibility in storing and updating data dynamically during program execution. Next one, lists are enclosed with square brackets and allow storage of heterogeneous elements like integers, strings, or even other lists. Their structure makes sure they are versatile for real-world program solving. A list supports dynamic insertion, deletion, and replacement of elements, unlike tuples which are immutable. This allows programmers to modify data structures as per changing requirements. Then lists provide powerful built-in methods such as append, insert, remove, and pop that simplify data manipulation, making them a crucial tool in everyday Python programming. Uh, Python lists supports indexing, slicing, iteration, allowing efficient data access and traversal. Combined with mutability, they serve as a foundation for making stacks, queues, and other dynamic data structures. Next is the common operations and methods done on list. So the first one is appending. Appending adds an element to the end of a list using append. It expands the collection dynamically, useful for building lists step by step without needing predefined size. Second one is slicing. Slicing extracts specific parts of sequences of list tuple string using start colon end colon step. It creates subcollections efficiently without loops, supporting negative indices for reverse access and flexible data handling. Next one is popping. Popping removes and returns an element from a list using pop without index. Uh, it removes the last item, enabling stack-like behavior, undo operations, or dynamic list management. Then it is remove. The remove method deletes the first matching element from a list by value, not index. It is useful when eliminating specific items dynamically, maintaining order, and cleaning unwanted data. These are the methods used for enhancing list manipulation and flexibility, and the use cases and examples of list. First one is storing. First example is storing student names. A list can store multiple student names dynamically. For example, students in square bracket in quotes Amit, comma Sarah, comma John. Next example is shopping cart. List can track items added or removed in an online cart. For example, cart is equal to milk, bread, eggs. Then marks of students. Store subject marks for calculations. For example, marks is equal to 85, 92, 78, 90. Next is to-do list app. A list helps in task management by updating tasks dynamically. For example, task is equal to in square brackets study, exercise, project. The next data structure is tuple. The properties and immutability. Tuples are ordered collections, meaning elements maintain the sequence of insertion. This allows access through indexing and slicing, ensuring reliable retrieval of data in the exact order they were stored. Tuples are heterogeneous, means it allows storage of multiple data types like integers, strings, floats, or even nested tuples. This versatility makes them useful for grouping related but diverse information together efficiently. Then tuples are immutable, meaning elements cannot be modified added or removed after creation. This immutability ensures data integrity, meaning it is ideal for fixed records and ensure unchangeable datasets. So next is when to use tuples over list. Tuples are ideal when data should remain constant and protected throughout program execution. They prevent accidental modification, ensuring critical information like configuration settings remains safe and unchanged. Second one is tuples are faster than lists in iteration and access because of immutability. They are best for performance sensitive applications where data does not require frequent updates or modification. Tuples can be used as dictionary keys unlike lists. This makes them useful for mapping fixed data pairs like coordinates, employee IDs, or product details requiring constant reference. And some of the extra points to add about why you use tuples over list is hashable dictionary keys. Tuples being immutable can serve as dictionary keys unlike lists. This makes them valuable for mapping composite keys such as coordinates, multi-parameter combinations, or database record identifiers in fast lookup operations. Next is performance efficiency. Tuples consume less memory and offer faster iteration compared to lists. They are preferable when handling large fixed datasets where performance, lightweight storage, and speed are more important than mutability or frequent updates. Next is returning multiple values. Functions often return multiple values or using tuples. Since tuples are immutable, the returned data remains secure from accidental modification, making them reliable for returning structured records, grouped results, or aggregated computations. Then the semantic meaning. Using a tuple can signal that the collection represents a fixed set of items not intended for modification. This improves code readability, communicates intent clearly, and prevents accidental logical errors. Next is accessing and manipulating tuples. Tuples support indexing and slicing similar to lists but do not allow modifications. Operations Operations include concatenation and repetition for new tuples. Um, Nested tuples are accessed with multiple indices, enabling efficient extraction of structured, immutable data and manipulation of tuples. Tuples are immutable, so direct modification isn't possible. So for manipulating the tuple, you need to convert it into a list for editing, packing or unpacking or creating new tuples. This preserves immutability while still enabling flexible handling of grouped data. And third one is dictionary. Key value structure explanation. A key value structure stores data as pairs where each key maps to a specific value. Keys must be unique, while values can be duplicated, ensuring quick lookups and organization. Keys act as identifiers like student IDs, and values hold associated information like student names. This allows efficient retrieval by key instead of searching through entire datasets. In Python, dictionaries implement key value structures using curly braces with syntax like in curly braces name colon in quotes ria comma age colon 21. This provides fast access and modification through keys. Key value structures are highly efficient for searching and updating operations. Dictionary lookups are nearly constant time, which means O of n complexity, making them suitable for tasks like caking, indexing, or configuration management. And methods and common operations on dictionary. Methods and common operations on dictionary. First is appending elements, inserting elements, removing elements. So appending elements, the append function method adds new elements at the end of a list. For example, numbers is equal to 1, 2, numbers dot append of 3, which will give the result as 1, 2, 3 in square brackets. Then inserting elements, the insert method places an element at a specified position without replacing existing ones. For example, fruits is equal to apple, banana. If you insert fruits dot insert one mango, then in the index 1 the element mango will be added. Removing elements, methods like remove and pop delete elements. Remove deletes by value, while pop deletes by index or last element if not specified. The practical applications and example of dictionaries. Useful for configurations representing objects and fast lookups. Widely applied in caking, database modeling, and JSON-like data handling. Then storing key value point pairs. Dictionaries store data as key value pairs. This allows fast lookups, updates, and efficient organization of data structured. Counting frequencies. Dictionaries efficiently count occurrences of items such as words in a text. Useful in data analysis, natural language processing, and statistics to summarize and process large data. The conclusion is that understanding Understanding lists, tuples, and dictionaries is crucial for mastering Python programming because each data structure is designed with specific strengths that suits different scenarios. A string list provides flexibility through mutability, making them ideal for dynamic data sets where frequent addition, removal, or modification of elements is required, such as managing a shopping cart or handling student records. Tuples, being immutable, ensure data integrity and are better suited for fixed collections of values like coordinates or database entries, where protection against accidental modification is necessary. Their immutability also makes them faster and usable as dictionary keys. And last, dictionaries excel at organizing data through key value structures, enabling efficient lookups and updates. They are especially useful when handling structured data information like employee details, configuration files, or API responses. And that's it. Thank you.